digital electronics, logic gates. There are two signals, analog signal, digital signal. Analog signal is continuously varying and can take any value you want. Digital signal, it has only two states, two discrete states. This is 1 and here is 0. Here is a high signal or low signal. High signal is known as on state, low signal is known as off state. So there are only two states. So this is the difference between the graph. Here is a curve and here is a line. Analog signal, digital signal. Identify the graph that represents a digital signal. Option A, B, C. Which is the right option? A. Here is a -1. We don't have any reverse signal. And here B. It's not continuously varying signal. We don't have. C. The option is right. It has only the on state or off. On, off. On is the high, off is low. Mainly these many types of gates we have: not, or, and, nor, NAND gates. Here is a NOT gate. It has a single input and single output. If input is 0, the output will be 1. If the input is 1, the output is 0, which means here you have a high signal, here you will get the low signal. If here is the off, here is on. Here is on, here is off. In every gate we have a truth table. So it will be like this: input, either you give 0 or 1. Only these two signals we have as an input. Since it is a NOT gate, it has only one signal, only one input and one output. So it may be 0, the output is 1. If your input is 1, output will be 0. So it is very easy, just opposite. Here is OR gate. Here is a circuit symbol. It has two inputs, 1 and 2, only one output. Here is a truth table for OR gate. Two inputs are here, one output. Here two inputs are 0. Here is low, here is low, here it will be low. If either one input is high, the output is high. If both inputs are high, also output is high. So here you can write for the output. So here is input 0 and 0. Both are low. Here will be 0, low. So 0. If here is 0 and here is 1, I told you if one input is high, output will be high. So here one input is high, output is also high. Two input is high, also output is high. So this is the truth table for OR gate. Here is AND gate. This is a circuit symbol for the AND gate. There are two inputs, one output. Here, if you want to get the output high, both input should have on state, means here 1, here 1. Then you can see the output 1. If any one here is 0, which means low signal, the output signal is also low. So the truth table for A and B, here is output 0 0. both inputs are 0, output will be 0. One input is high, another is 0, also output 0. So here I change the signal. Now B is high, output is 0, no signal, it is off. In both terminals, if we give high, 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 here you can see the signal high. This is the truth table for AND. Now we have NAND gate, which means the AND gate is connected to NOT. It is like this. First you draw the AND gate. It has two inputs, and this output is taken as an input for NOT, and here another output. This is the final output. Final output. Here are the two inputs. So two input for AND gate will give you output, and this output will be given as an input for the NOT gate, and it will reverse the signal. For example, here is 0 0. If both signals are 0, low low, AND gate will give you 0 signal, and this 0 output of AND will be taken as an input for the NOT gate, and what is the final output will be 1. So this gate is known as NAND gate. The truth table for the NAND gate: in the AND gate, if both signals are high, the output is high. It is just opposite. If both inputs are high, so the output will be low for the NAND gate, because there is NOT gate will reverse the signal, final signal, and here all will have high signal 1 1 1. This is the truth table for NAND gate. It is NOR gate. The circuit symbol is like this. There are two inputs, one output, just opposite of OR gate. It is actually like this: one OR gate which is connected to NOT. Now example, in OR gate we have learned if either one signal is high, the output will be high, and this is the output for OR gate, and this will be given as an input for the NOT. Now the NOT gate will reverse the signal, will make it low. So this is how it works. Here is the truth table for the NOR gate. It is just opposite of OR gate. In the OR gate we have learned if either signal is high, output will be high. So here it is opposite, output will be low. In OR gate, if both inputs are high, output is high. So here is low, opposite. In OR gate, both inputs are low, output is low, but it is opposite. So here is 1. The application, it has many uses, especially it is used as an automatic central heating system, and it is used in security alarm system like burglar alarm, and also it is used in doorbell. Other applications are temperature sensor, pressure sensor. It is used in calculator display, turn on and off the LED, open or close security lock system, used in aircraft and many more. Here we can see one application for the street light is the automatic street light. How it works? Here is the circuit diagram. Here we have devices like switch. Here light sensor. Light sensor is light dependent resistor LDR, and this LDR signal is given to the NOT gate, and here is a input A B, and here is the input A. This input A comes from the switch. Here input B comes from the NOT gate, and NOT gate gets signal from LDR. Okay, here is the truth table. So I'm going to explain one. For example, I can explain this on, dark, on. Now the switch is on. Switch is on, which means it gives a signal 1, and here it is a high signal. Okay, and LDR is dark. If the LDR is dark, the signal is 0. So 0 input is given to the NOT gate, and NOT gate will reverse the signal into 1. So the input, another input for B is 1, and this is the OR gate. So if both signals are high, the output is also high. That means 1. So the street light is on. So here it is. Okay, now I can explain this, the last one, off, bright, off. So switch is off. So the signal is here 0. So the input A, now it gets 0 because the switch is off. The input is for the OR gate, one input is 0. And then what about the LDR? LDR is brighter. So bright of LDR will give the signal 1. So the input for NOT gate is 1. It will reverse the signal into 0. So the input, another input for B is 0. So in OR gate, both inputs are 0. Output is also 0. So the street light now off. So here is the condition. Another application, it is used in security alarm. Here you see, here we are using 3 devices. One is light sensor LDR, infrared sensor thermistor. It is connected to AND gate. So how it works? So here is the truth table. Here in the light sensor, if it is dark, the input is set as 1, high, signal is high, bright 0. Here is infrared sensor. If there is an intruder, it is off. No intruder, on. That is off. Here is given 1. On, it is set as 0. Okay, it will be given. It will be given. We have to analyze now with the truth table. Okay, here we can analyze one example. This example, dark. When the light sensor is dark and infrared sensor with intruder, alarm is on. Okay, in the dark time, intruder enters like in the bank. So the light sensor, here it is dark. Dark signal is 1. So the input signal for A is 1 for the AND gate. And what about the intruder sensor? Sensor is here S. S, there is here is one intruder. So intruder is on. No intruder means 0. Intruder is 1. With intruder, the signal is here 1. So here in the B, you get 1. In AND gate, you know, if both inputs are high, the output is also high. If any one of input is low, the output will be low. So here now the output signal is 1. 1 is here on. So alarm starts work. So here is the application. Okay, thank you very much for watching this video.